In this video, we are going to discuss the advancement in technology between the Tomcat and the Super Hornet. But before we get onto the video, I would like to first give you a clear picture of what a fighter jet is and its purpose. A fighter aircraft are fixed-wing military planes that are primarily used for air-to-air combat. The role of a fighter aircraft in a military conflict is to establish air superiority in a battlefield. Dominancy of the airspace above a battlefield allows bombers and attack planes to bomb enemy targets tactically and strategically. From what I've just said, you can see that fighter jets play a very important role in combat. They offer the military and the soldiers advantage over the other sides because they can go faster in places that you can't reach by foot, and they can attack tactically and strategically, and that will give you an advantage to win the war. Now we're going to discuss the F-14 Tomcat into details because we're going to be comparing it to the Super Hornets. The F-14 Tomcat. The F-14 Tomcat is a supersonic twin-engine variable with a sweep wing and two places for fighter jets, designed to attack and destroy enemy aircraft at night and in all weather conditions. The F-14 Tomcat was designed as both an air superior fighter and a long-range naval interceptor. It was designed to improve on the F-14 Phantom air combat performance in almost all respects. The twin engines are housed in a widely spaced nacelles between the fuselage and the wing. It can carry AIM-54 Phoenix, AIM Sparrow, and the AIM-7 Sparrow anti-aircraft missiles. The F-14 wing sweep can be varied between 20 degrees and 68 in flight. The Central Air Data Computer maintains wing sweep at the optimum lift-to-drag ratio as the Mach number varies. A symmetric wing sweep has flown safely during the test that was discussing the variable geometric and aerodynamic designs. In terms of engine and structure, the F-14 was initially equipped with two Pratt & Whitney TF30 augmented turbofan engine, each rated at 93 kN of thrust. This enables the aircraft to attain a maximum speed of Mach 2.34. The performance of a TF30 engine became an object of criticism. The avionics and flight control. The F-14 cockpit has two seats arranged in tandem, outfitted with a rocket-propelled injection seat. The aircraft's large nose contains two-person crew, several bulky avionics systems. The Central Air Data Computer is the onboard flight control system. The armament of the F-14 Tomcat. The F-14 was designed to combat the Soviet anti-ship cruise missile and bomber threats. The Tomcat was to be a platform for the AIM-54 Phoenix. Iran made use of the Phoenix system during the 1980 and 1988 Iran-to-Iran war. The specifications of the F-14 Tomcat. The F-14 Tomcat has a wingspan of 19.545 meters and a lower wingspan of 11.646 meters, wing area of 52.5 meters square, wings only, max takeoff weight of 33.350 kgs with a fuel capacity of 7.348 kgs internal fuel. Optional 267 US Galleons external tanks with a maximum speed of 2.485 kilometers per hour at altitude and a range of 1.800 nautical meters. With guns. With missiles, it has AIM-54 Phoenix, a AIM-7 Sparrow, AIM-9 Sidewinder, AIM-7 Sidewinders, air-to-air missiles, airborne port system, and an airborne infra search and search naval navigation system.
Now, I am going to talk about the Super Hornet. The FA-18 is a fourth-generation twin-engine, supersonic, all-weather, carrier-capable, multi-role combat jet, designed as both a fighter and attack aircraft. It was designed to be highly versatile due to its avionics, cockpit display, and excellent aerodynamics characteristics, with the ability to carry a wide range variety of weapons. It can perform fighter escort, fleet air defense suppression of enemy air defense, air interdiction, close air support, and aerial reconnaissance. Its versatility and reliability has proven it to be a valuable carrier asset. Now I am going to talk about the design of the Super Hornet. The Super Hornet is about 20% larger, 3,200 kg heavier empty weight, and 6,800 kg heavier maximum weight. It has an advanced cockpit which helps decrease the workload for the pilot. It is designed to be equipped with an aerial refueling ARS for refueling of the aircraft. The design of the Super Hornet shows two extra wing hardpoints, have a wingspan of 40 and nearly 45 feet. ARS includes an external 1,200-liter tank with hose reel on the center line, along their four external 1,800-liter tanks and external tanks. Going into detail about the specification of the Super Hornet. Starting with the nose. Block 3 has advanced APG-79 electronically scanned array radar with the ability to see targets, both large and small, and develop weapon quality track for everything. It has innovative tactics. The comfort fuel is located on top of the leading edge extension. They enable longer range and increased loiter time. The shoulder-mounted tanks can carry 3,700 pounds of fuel and reduce drag, allowing aircraft to operate longer, go faster, and carry more weight. The Super Hornet has a new 10,000-hour airframe, which provides greater than 50% increase in the life cycle of that frame used. It also has an advanced cockpit station. The ACS provides several things for the aircrew, but most specifically, it has a large area display capable of swapping in all sorts of different display. The Super Hornet has an improved radar cross-section, which makes it harder for threat radars to see. It also has a dual engine, which provides incredible capability and redundancy in all environments of all regimes. It also has an advanced electronic warfare capabilities, reduced ballistic vulnerability. Now, we are going to explain the measuring devices that are used on jets. Airspeed is measured using the airspeed indicator. This is a device for measuring the forward speed of the aircraft. The airspeed indicator uses the aircraft pitot static system to compare the pitot and static pressure and thus determine the forward speed. The other two flow measuring devices that are used are ultrasonic flow meter and a mass flow meter.
On the calculations, we got the speed of the jet, that is 260 kilometers per hour. And then we take the initial velocity as 0, and then since we got the speed, that means we can get the final velocity. The final velocity, we converted the kilometers to meters per second. Then that way we got the speed, the velocity, and the velocity it should be 72 meters per second. And as you can see on the screen, I'm still calculating this meters per second. I was just trying to convert. I was just trying to make sure that you can see where did I get the 72 meters. And also we get the length before the aircraft take off. That is 80 kilometers. I'm sorry, that is 80 meters. That means it's a displacement. We use the projectile motion to calculate the acceleration. The equation is vf squared, v initial squared plus 2a delta x. We use that equation so that we can find the acceleration first, because we want to have the time before it take off, before the aircraft take off. So as you can see, I'm trying to calculate the acceleration, and we got the acceleration, and the acceleration is 32.4 meters per square second. And since we got the acceleration, that means we can use the second order differentials that we used on the maths. So we got the second order and we integrated the second order so that we can get the time, because since we use the second order, we take velocity as independent, then we take time as the independent. So we try to calculate the time, and then we have the constant, that is c. Then we took the initial time is 0, then that means also on the dv side is 0. That is why I just said c is equal to 0. Then we also use the we try again and integrated. Then we got the displacement, that was 80, so that we can get the actual time that the aircraft take off. So the actual time that the aircraft take off is 2.2 seconds.